Okay, the second part that we are learning is arc length and sector area. So this is related to one circle. So one circle, the middle of the circle, we call this as a center. So you have to be very familiar with the terms used in here so that you are able to answer the questions. So if I have a line that goes from the center to the side, we call this as radius. So this is radius. And if we have another one from here to here, this is another radius. What do you call the area that is inside here? This area is called a sector. The area is called the sector. And what do you call this part that is the length? We call this an arc length. Another thing that you need to know is a straight line that goes from here to here. This line is called a chord. And the area that is here, we call this as a segment. Once you get this term right, we now talk about segments. So this is a circle, and just now we talked about this being a segment. Well, it's correct. What about this side? This one is also called a segment, but it is a bigger one. So how do we name the bigger segment? In maths, this is called the major segment, and this one is called the minor segment. So major means big, and minor is the small one. So this also applies for your length. So let's say we have an arc length that is a smaller one, and this one is a bigger one. So this is an arc. This big one is also called an arc. But how do you call the smaller arc? We call the smaller arc as a minor arc, because minor means small. What about the bigger one? We call the bigger one as a major arc, because major means big. So after we have learned that, there are two main things that we need to calculate. So going back to the circle. This is the arc. The arc is a length. It is like some sort of like a length, so the unit used is like centimeter. And another thing we need to know how to calculate is the area of the sector. So the sector is an area. It's the area that encompasses this part. So the unit is some sort of like a unit square, like a centimeter square. So there is a formula to calculate arc length, and it is L equals to theta r. What does this mean? L stands for length, which is the arc length. What about theta? Theta, as we have learned before this, a theta is actually a representation of an angle. So this is an angle, and in this case, it is an angle in radian. Okay, what about r? What does that mean? R is your radius. Your radius will be, let's say this is a circle. So this will be the radius, the length of your radius. So for example, if one question is given, for example, we have a circle and your radius is maybe 2 centimeters and your angle is maybe 3 radian. How do we calculate the arc length? So we use the formula that we learned just now. L equals to theta r. What does that mean? Theta, in this case, it is the angle in radian, which is 3. And r will be your radius of the circle, which is 2. So 3 times 2, what do we get? 6. What is the unit for our length? Because this is in centimeter, the arc length will also be centimeter, so it will be 6 centimeter. So as mentioned, there are two things that we need to calculate. One is the arc length, the other one will be the area of the sector. The formula for the area of the sector will be A equals to half theta r squared. So what does A stand for? A stands for the area of the sector. Theta, the same as the previous one, theta is still the angle in radian, and r will be the radius, but this time you need to r squared. So using the same circle, how do we calculate the area of the sector? The area of the sector that we are talking about is this one. So how do we calculate this piece? So for area, it's equal to, we copy down the half. What about the theta? In this case, the theta is 3 radian. So 3. And what about r? The radius is 2. So 2 squared, because there is a square here. So from here, we need to half times 3 times 4. So what do we get? We get 6 centimeters squared. Why do we need to write a square? It is because this is an area and therefore your unit needs to be in centimeters squared. So let's say if we have a question given a circle, okay, with the radius of 5, and let's say an angle of like 3 radian. If the question says find the arc length, how do we find the arc length? So we know that L equals to theta r from the formula that we learned just now. So what is our theta? Our theta in this case is our angle in radian, which is 3 times your radius. Your radius is 5 centimeters. What do we get? 3 times 5 is 15 centimeters. So this will be here, the length of your arc, which is 15 centimeters. If we want to find the area of the sector, what are we talking about? The area of the sector is this piece here. So area, according to the equation here, area equals to half theta r squared. We just fill in whatever we need for the gap. So half, we just copy it down. Theta in this case is 3 radians, so we times it by 3. What about r? R is our length of our radius, so radius in this case is 5 squared. So what do we get from here? 3 times 5, we get 75 divided by 2. And it will be equivalent to 37.5 centimeters squared. If you write it in this sort of format, that is fine. Or if you want to write it as 37/1/2 centimeters squared, that is fine too. Okay, sometimes questions can be quite tricky. So for example, if we have a circle, so let's say the radius is 8. And instead of giving, because we are used to answering when the angle is given, but sometimes it's the arc that is given. So if we want to find the angle, how do we do that? So we still use the same formula. Which formula should we use? What is this? This is an arc length. So there are only 2 formulas to be used, either the arc length or the area. So in this case, we have to use the arc length formula, so which is L equals to theta r. It's okay if you don't understand how to fit everything in the first place. You just copy down the formula and see which one could be fit into this equation. So 8 is a radius, so 8 is sort of like the r. And what do we have? We have a 12 centimeter. What is this? This is actually your arc length. So your length is 12. So this will become 12, copy down the equal, copy down the theta, times by your 8. If there is no times in between and you can see 2 different variables, it is a times. So how do we move 8 to this side? We need to move 8 to this side so that we can find the theta. In order to move 8 to the other side, we need to divide both sides by 8. So what do we get? We can cancel this and we can see that this is the theta. So theta equals to 12/8, or if you want to simplify this, theta equals to 1.5 radian. So this is how to get the radian when radius and the arc length is given. So if the question further asks you how to get the area of the sector, it will be very easy then, because the area has a formula of A equals to half theta r squared. And because we know the value of theta already, and we know the value of r, do you think that calculating the area is possible? Yes. So it's half times theta, which is 1.5, times r squared, which is 8 squared. And from here, we will easily get the answer, which is 48 centimeters squared. So I hope you understand how to calculate the area of the sector and also the length of the arc, because this is what that is covered in this video.